are of two types. The first operation is we can choose two elements with the equal values, right? So if I choose two elements, so it should be of equal values. Let's say 2 2, let's say 3 3, and then what I can do is I can delete them from the array, which means remove them from the array like this. Okay, that's great. Now other operation is that instead of 2, I can also try to choose the 3 elements from the array, which should also be equal, and then apply the same operation, which is delete them from the array. Ultimate goal is to return the minimum number of operations required to make the array empty, which means all the elements in total should be deleted with these two operations. Let's say name it as operation 1, name it as operation 2, and the minimum number is required to actually delete those. And lastly, if it is not possible to delete all the elements, return the -1. Now let's see, like before we go on to a case, we can simply replicate these cases, that what should be the minimum number of elements or minimum number of operations required to actually delete all those elements. For sure, if we want to have a minimum number of deletions, we will try to delete maximum number of elements in one go. In one go, as in one operation, I'll try to delete maximum number of elements. So what I thought of, let's say, okay, we have all these as of the same values. So like blue color, one color represents same value. So I just thought, okay, I just have only one color, as in one value, and it is 6 times. So what I will do, I know that more number of elements I can remove in one operation, the lesser number of operation I would require. So I thought, let's try to delete 3 in one go. So in this, if I have to delete 6 elements, and if I choose operation 2, which is in which one go in I have to remove 3 elements, so I would require 2 operations. While if I had used, so operations required are actually just 2. Here operations required are 3. As you can see, 1 2 and 3. If I choose to delete these 2 elements in one go. So one thing you for sure got to know, that every day or any day I will try to choose operation 2 over operation 1, because I want minimum number of operations required to be deleted, because more number of elements I can delete in one go will give me lesser number of operations required. Okay, so what I did was same, n by 3, basically 6 by 3, giving me 2 operations to remove all the, again remember that it is of all the same color, as in same number or as in same values. Okay, but here what if n equal to 7, which means, okay, I added one more element in this, right? Now I'm just trying to replicate, okay, add one more element. Then you would have said, bhaiya, as you told that you will do a n by 3, so by this n by 3 you will get actually 3. So you will say, okay, 2 is there, but you also saw, bhaiya, that n modulo 3 is actually 1, which means, okay, one element is still remaining, but I don't have any operation to club one element. So bhaiya, this operation is wrong, right? So answer would not be 2 plus 1, which means earlier by this example what I could have said was that n is 7, so I'll club 3, and remaining will be for sure less than 3. I can club that. So for this it will be n by 3, for this it will be just a 1, so n by 3 plus 1 would give me a 3. Although logically you will see, okay, bhaiya, it is incorrect because last operation is not given to us, but actually it is correct. How? Because this last pair, which is a 3 1 pair, and for sure if it would have been a 2, which means if it would have been a 2, you could have simply paired that up, because you had operation number 1, but if it was only and only 1, then what you can do is, okay, last 3 and 1, you can modify that as 2 and 2. That's always possible. So last 3 and 1, I can modify that as a 2 and 2. So ultimately n by 3 plus n mod 3, and again n mod 3 should actually be a 1 or a 2, because you saw if it is a 2, then I can pair it up and make it as a 1 group. If it is 1, still I can just modify one of this n by 3s and then again use that remaining one element for the other pair, last pair, and thus get the value. So for sure this will also work, which means getting the last n by 3 n by 3 and this one element and getting this up. Bhaiya, but you in this operation you tried to use one of the previous 3 values. So basically you are saying that your count, or basically you should be having 3 values previously. That is what you are saying, because if it would have been a 3, you would have clubbed it up. Okay, but that's great. Now if it was only this one element, this one single element, nothing beside him, then how will you club this? Basically, how will you like club these 2 and get 1 from these 3 and then club again 2? It's not possible, right? That is the reason. If the count is only 1 itself, which means if this is not there, which means my n by 3 is actually a 0, or basically I can say that my n mod 3 is 1 and n by 3 is 0, it ultimately means that I have my count as 1 itself. So it will not possible. Then I can return a -1. That is the other case which we will handle. Again, no worries, we'll actually look at the example itself, and ultimately this is what we discussed. If in the last we have 2 that we can actually take, in the last n mod 3 is actually 2, which means I have remaining 2 elements. I can club them up. So for corresponding that, I will need one operation. For this also, one also I will need one operation. Why? Because one operation is just saying that I will club it as a 2 elements, and how I'll get one more element from the previous group of 3. And last but not least, if I have just a modulo of 3, just simply have a modulo of 3. If we go ahead and look at the example itself, it's pretty simple. It is a one test case which was given. For 2, I clubbed all the same elements. Its count is 4. So as we saw earlier also, count is 4. So answer should have been 4 by 3 plus 4 mod 3. Again, 4 mod 3 is not the implementation. I'll add a 1 if my 4 mod 3 is either a 1 or a 2. Now you will see mod 3 values will have only 3 values, which is 0, 1 and 2. So I'll just say, okay, if my 4 mod 3 is not equal to 0, then I'll add a 1 corresponding to it, which means the last group. Ultimately this last group I was referring. But I also knew that if my count is actually not 1, which means if my count is not 1, so I can get one of the elements from the previous group of size 3. So ultimately I can make it as a group of size 2, which is corresponding to the one right here, and also the previous group will actually become of size 2, but still it can form a 1 group. So that's the reason this can be represented as exact same way. Now for the 3, it's just n by 3 itself. For the 2, it's again n by 3 plus n mod 3, which means n is not like nothing but the count, I can say. And for sure n mod 3 1 corresponding to if n mod 3 is not equal to 0. So ultimately it is nothing but count by 3 plus 1 if the count modulo 3 is actually more than 0. Now in the second case, as you can see, for 2 I have a group of size 3. For 1 it's of size 1, and that is the case when it goes wrong, because in case of -1, like in case of just size 1, I cannot get anything, which means I cannot get the previous 3 and then get one of the ones and then pair them up and then pair them up and then the remaining ones I can pair. That's not possible because I don't even have the previous group. So that's the reason. Just if I have only one element, so answer is like just return -1. It's exact same stuff. I used a map to keep the track of the count of elements. Okay, that map keeps a count of every element. Now I just went on and find out my answer. I went on to this map. It's a key value pair where the key is the element and value is the count itself. Now the simple case which we saw, if the count is 1, then if the count is 1, then it's not even possible. If the count is 1, then it's not even possible. So simply have a -1. Else I can simply say it will be count by 3 plus count modulo 3. If it is more than 0, then corresponding to this I will add a 1 value. So this says if the condition is true, add a 1 corresponding to this, and that is how I can simply get my answer. So the only thing which you had to get or make sure, again you can write it as a if condition also, this entire thing as a if condition also, that if your last element is actually just like remaining element, which means n, which means your count mod 3 is actually a 1, then you can club that up with the previous, so your count should be more than 0, like more than 1. So this is all condition you can also write, but you can club all these conditions same into this one condition itself. That's the reason we wrote it like this. The only star condition is this one, that if if your count mod 3 is actually a 1. That is it. Cool. Thanks for watching. Bye bye.